everyone, welcome to the lecture 32 of course Climate Change Extreme Events. In this particular lecture, so in the previous lecture we have primarily talked about what are the emerging technologies where we can use for more better predictions of climate extremes in different parts of the world. We have primarily talked about the predictive capability of AI, ML and all these advanced tools. Then we have talked about big data which are coming from climate models, reanalysis product, then it is coming from, let us say, multiple different satellite sources, observational networks like that. So, basically these are the data set where we can leverage, we can do that analysis, and then we have also talked about the data set which is coming from the citizen science or citizen contribution data set, where we can acquire the data set and we can integrate with our analysis and we can use it for better understanding of the climate extremes in a different regions like that. In this lecture, we will primarily talk about how we can integrate the remote sensing and AI in detection of the climate extremes, which basically we are trying to integrate our earth observations and artificial intelligence. So, what we are seeing currently lots of satellites which are evolving, lots of data set they are recording. At the same time, we have also the cloud computing system, for example, Google Earth Engine, and at the same time in the Google Earth Engine and integration of the Google Earth Engine with your artificial intelligence, we have multiple different types of algorithm which has been developed. So, which means we can integrate our earth observation with the artificial intelligence more easily, and based on that we would be able to do some sort of more better insight about climate extremes analysis in different parts of the world. So, that is basically bridging the gaps which were there when we were not very in that position of high artificial intelligence and earth observation data set. So, in this particular lecture we will primarily talk about understand the role of remote sensing in monitoring climate extremes. We will explore AI techniques for detecting the and forecasting the extreme events. We will review some sort of case studies of integrated remote sensing AI systems, and we will also discuss opportunities and challenges in applying these technologies. So, what is remote sensing? So, remote sensing is an area where we have different types of sensors which are circulating around earth and collecting the data set. What type of acquisition of the earth data from the satellite or airborne system? What kind of the sensors these satellite system has? It could be optical, for example, the MODIS satellite or Sentinel-2 or Landsat, or radar data which are coming from, let us say, Sentinel-1, or let us say we have thermal data which are primarily sensing the heat which is coming out from the surface. What is the advantage of remote sensing? Because it is basically we are assessing a property of a earth surface from a certain distance. So, that is why we would be able to cover a large area coverage. We can do some sort of frequent observations, hourly, daily, like that. For example, if you look at 3-hourly TRMM mission, that is basically covering the rainfall measurement in every 3 hours. So, similarly, we would be able to have sub-hourly, sub-daily, daily, and like that, this kind of the frequency we have. So, this is a one figure which tells about these different types of satellite observational system platforms and their operating altitudes. If you look at ground based, these are situated at the ground location and calculating the different variables at the ground stations. When we are talking about, let us say, in 100 meter and something like that, there are some sort of small UAVs, unmanned aerial vehicles that can be used to collect the data for very low altitude heights, and that provides a very high resolution data set. There are satellites which are revolving around earth at a very higher elevation, 10 kilometer, 100 kilometer and 1000 kilometer and more than that. So, which means as you increase the altitude of your the circle, it will basically, or radius, it will basically increase the size of your resolution, which means you have poor resolutions like that. So, therefore, depending upon the need of the data set, let us say if you are talking about UAVs, UAVs are basically covering only a smaller location and with the precise or very high resolution data set. But if you are talking about geostationary satellite or remote sensing satellite or like multiple different, these satellites are basically located at a very higher altitude, and therefore, it has a capability of covering whole globe with not very fine resolution, but it will cover the whole globe with certain resolutions capabilities like that. So, in a summary, using the remote sensing data set, we would have a very fine resolution data set, and we also have a very large area coverage data set with not very high resolution, but moderate resolutions like that. And depending upon the data types, we would be able to do some sort of analysis. Let us say if you are focused on the local analysis, local impact of climatic extremes, we will focus on those data set which are derived from low altitude aerial vehicles. That will provide more high resolution data set and can be useful for local areas. But if you are talking about this regional or global analysis, we will basically look into it the higher altitude data set, and that will cover more coverage areas, and then that will cover, let us say, the large climatic extreme processes like that. So, what is the introduction of AI in climate science, why it is important? So, first we talked about what is exactly remote sensing. Now, we will talk about what is exactly AI. AI or machine learning or deep learning is basically tries a kind of a model based on neural or based on some sort of a statistical theory that basically look into the historical pattern, understand the historical behavior, and based on the historical behavior, they try to predict what is the behavior of a particular variable or particular climatic extremes in few steps after that or future steps, or let us say how well we will be able to model the historical behavior of a certain variable. So, that is basically the overall goal of these ML and DL model. This can be used for pattern recognition, can be used for classification, can be used for anomaly detection, can be used for predictions. Why AI? Because it has a high dimensional data set it can handle. It can also look into the non-linear relationship between the data set and can efficiently provide a very good estimate of how systems are behaving. What is the non-linearity? Let us say if you look at multiple processes in the natural world, it is not linear, it is behaving some sort of non-linearity. There are some sort of random occurrences of different processes as well. So, these kind of the noisy data set or non-linear relationship data set, the AI or machine learning or deep learning kind of tools are very well efficient and can be use that tool with a very lower amount of data set and can give us a good estimate. On the other hand, let us say if you are talking about physical based modeling, if we do not know about the physical processes, we may not be able to model that. But if you do not know about the physical processes, however, our data sets show some sort of variability with our input data set, we can try to model with the AI based model, because these models are not bothering about the physical processes unless you are using some sort of hybrid AI kind of thing. So, data collection, data analysis is one of the major part of this AI setup modeling. Reanalysis data we can take, observational data set we can take. Pre-processing is primarily we have to detrain the data or denoise the data or some sort of gap filling in the data. Then this is the once we have done the data cleaning and data analysis, that data goes into the AI methodology, which can be your machine learning, which can be your computer vision, multiple different types of AI which basically understand the explainable AI or causal inferences between different variables. And then basically we can also integrate some sort of natural language processing, that is called NLP. When we have these kind of the AI methodologies, it will basically gives us predictions. It can also gives us the attribution, which variables are primarily affecting that climate extremes more than compared to other, like that, or basically let us say what is the patterns and trends and what is the causal relationship in the different types of input and output data set. Once we have this output data set, we can compare with our historical data, and then we can compare, let us say we have done some sort of predictions. We can use these predictions with our historical observation data set, and we can then refine our model or refine our hypothesis or model improvement, and then we can rerun that analysis, and that is called calibration and validation of our results. So, this is very precise summary of how AI ML model works. We have some sort of input data set which can be your climate variable or land surface characteristics variable or geomorphological variable or geological variables, like that. You feed that variable into the model, which could be your machine learning, AI and deep learning model. There are some sort of mathematical equations in that model, and that basically tries to look at the interrelationship between that variable. Once they have established it, they basically try to look at the output of the variable, and then you basically model the output based on the learning of your climate variables with their interactions with the output. You can compare, and then once if it is satisfactory, then you can set up that model for predictions as well. So, this is basically how we can use the AI in the climate science. How we can use the remote sensing in the climate extremes. So, there are several areas where we can use remote sensing application in the climate extremes. One potential area is flood detection. So, for example, synthetic aperture radar data for real time flood extent mapping. So, if a flood is happening in a certain region, if we have a real time data set, we would be also able to map what is the total area of inundation of a certain region, whether a particular floods are more catastrophic than the previous floods, or how many areas, or let us say which area are more frequently flooded because of the flooding events in these particular regions, like that. Then another potential area of the climate extremes are heat waves surveillance, which can be used based on some thermal infrared imagery for surface temperature, and can model how the imageries or temperature are rising across different areas, whether is there any role of let us say land use, land cover or forested regions, like that. That hypothesis can be checked using this kind of the thermal infrared imageries, like that. Then there is a drought monitoring we can use using the NDVI, normalized difference vegetation index, and the land surface temperature from the MODIS data set, that we can compare together, and we can try to analyze what is the role of, let us say, drought, and what is the role of drought on the NDVI pattern, whether NDVI has any role play on the drought patterns in the different parts of the country. Here it is a particular example for China, but it can also be done for multiple other countries and states as well. There is another area of remote sensing is basically where we can do some sort of climate extremes monitoring, is cyclone tracking. So, suppose we would be able to do some sort of multispectral and microwave data set for storm monitoring. We can track their path. We also try to predict which area of this particular the cyclone is basically likely to collide with a different region, and that we can also predict beforehand when the cyclone is basically revolving around a certain regions, like that. So, this is all we can do using the high resolution remote sensing data set plus near real time data set. When we have near real time data set, we would be able to, or real time data set, we would be able to do some sort of real time analysis, and we can then inform to the local public or the concerned authority in that region, okay, this is the flood extremes or flood extent because of these flood events which are happening in certain region, or what is the likely path of a cyclone in a, let us say, Odisha or some coastal regions like that. So, this is how basically these remote sensing data sets are very useful in detecting the extreme events. AI techniques for the extreme events, we have done multiple types of, we have seen people have worked on multiple types of models. For example, they have worked on supervised learning, where primarily they work on the random forest or support vector machine for classification things, or there is a unsupervised learning. So, basically they are talking about clustering algorithms for anomaly detection and all. So, when we are talking about the supervised learning, we have to supervise our techniques with the external data set. When we are talking about the unsupervised learning, we do not provide any external data. We tell to the algorithm that whatever the input data is, you just use it and then you try to mimic some sort of cluster in or anomalies in the data set. There is some sort of deep learning algorithms, which is convolutional neural networks, CNNs, or image based event recognition, that can also be done, or long short term memory based networks for time series forecastings. So, if you look at this particular figure, let us say if you are talking about supervised learning, you have to classify different parts or different types of events or flood characteristics or drought characteristics like that. We can use supervised learnings or unsupervised learning. In the supervised learning, there are two techniques, regression analysis and the classification. In the regression analysis, we can do linear regression, we can do polynomial regression, we can do SVR, we can do some sort of logistic regressions, and for classification, we can do some sort of decision tree, random forest, SVM for classification. In the unsupervised learning, we would be able to do some sort of clustering, where we can use k-means, hierarchical density based and dimensionality reduction algorithm we can also use in the unsupervised learning, for example, PCA, TSNE and auto encoders. Then there is a reinforcement learning algorithm, where we can do some sort of Q learning, policy gradient, actor critic and all. And there is a deep learning algorithm, where we have ANN, CNN, RNN, RBN, autoencoder, DBN, GAN, like that. There are so many different deep learning models. So, we would be able to, if we have the historical data set and the primary objective is to do some sort of predictions or some sort of classification or some sort of regression analysis, we can choose different types of models based on their accuracies, and then we can compare, and then we can select a particular model for that particular purposes. Let us say if you have a remote sensing data set for flood inundation area for multiple time period, let us say, and let us say if you feed that input data into a one particular AI model, and then you tell to the model that okay, what kind be the extreme climate situation in a certain region, that model may be able to provide what is the extreme situation of the flooding in a region. So, these are the historical pattern, how the pattern are evolving when we have higher flood, lower flood or more frequent flood in the recent times, like that. And based on all these learning, AI basically tells about okay, which area is likely to be inundated if extreme flooding events will occur in the certain regions, like that. So, this is one of the case study where people can use the flood detection using remote sensing with artificial intelligence techniques. So, this is a basically a region Assam in India, where the author has used the Sentinel-1 SAR, Sentinel-1 which is radar data with the terrain data. Why radar data? Because Sentinel-1, when we are talking about basically the monsoon period, that period it is possible that we have some cloud cover, and because of the cloud cover, the optical data set may not be able to penetrate in the clouds. So that we have some sort of pixels which are missing because of the cloud cover. So that problems we have to sort out when we are using some sort of different types of data set, radar or different types of data set. So here author has used Sentinel-1 data plus the terrain data, and then basically try to look at some sort of model which is a random forest classifier for water detection, and then basically based on these mapping and modeling, they will be able to tell about the accurate real time mapping of inundated areas. So this is the Assam region where we have a flooded susceptibility across whole region, and then basically there are some region which is non flood susceptibility, and there is some region where we have flood occurrences between 2019 and 2021 which is observed. So based on this basically analysis, they have fitted into that our that AI or this random forest model, and they are able to accurately classify those water detections and water areas which has been inundated, and that can be done by using these kind of the classification systems as well. So this is a one example how flood detections or flood spread analysis can be done using remote sensing with some sort of machine learning and AI tools like that. There is another case study of the heat waves risk mapping with the satellite and deep learning model. This is the Delhi part of India where the author have used the MODIS LST, land surface temperature, and the socioeconomic data set, and then they have used also the CNN, convolutional neural network model for identifying the urban heat hotspots. What are their outputs? They have basically tried to look at those hotspots which are high temperature compared to the other areas, and trying targeted planning for cooling interventions, why it is important. So this is the image where we can look at there are certain areas which we have land surface temperature are very high, and which are most of the time these areas are clustered around those areas where we have high density of the urban clusters or buildings. So this is basically we would be able to tell about those regions where we have higher clusters, lower vegetations and all. We can tell kind of a different infrastructural construction or planning or sustainable building design or sustainable city planning like that, so that we would be able to provide more greener spaces in those areas and can basically reduce the increasing LSTs in that particular regions like that. What is the benefits of integration of remote sensing in AI? Because when we are integrating the remote sensing and AI, so as we have just discussed that AI has the capability of detecting some sort of non-linear pattern in the data set. Once we are able to detect the non-linear pattern in the data set, we can basically look at how accurately we would be able to predict that pattern in the different time steps as well. So rapid detection and response supports disaster management operations. So if we have larger area which are covered by the remote sensing product, and we would be able to apply the trained AI model, and then if let us say look at how the flood behavior is likely to occur in that particular region, or how the flood extent are evolving or will be evolved, let us say a certain amount of water, that can be done using integration of the remote sensing and AI, and can be very useful for disaster management operations. Scalability and automation, for example, if we have already done some sort of tools using the remote sensing, that can be also applied in some other region, and that can be used for their purposes also, and can be used apply in multiple different areas. So that is the scalability. And automation means we have to just give it to the input data set, and that will provide the output of the data set like that. So if a one model has been already developed that and has a very good accuracies, that can be tried to look at different areas for scalability and automations like that. When we are talking about remote sensing in AI, this is also improved accuracy because we have high resolution data set, high temporal recall data set, and that basically required for AI. So, that will improve the accuracy for sure, and then basically it will also enhance the classification and forecasting accuracies like that. So, suppose we can think about monitoring the drought. We have multimodal data set, satellite imagery, climate variables, static features. We can integrate together in the AI using some sort of neural integration gradient or neural network algorithm, and based on that we can basically tell about suppose we are taking air temperature, soil moisture and vegetation health. We can develop some sort of patterns out of it, and then we can look at okay, which part of the year or which day or which area is highly prone to drought, kind of frequent drought occurrences. Similarly, it can be also be done for some sort of heat waves analysis, where we can do time series, we have a text, we have heat wave data set that could be used for prediction with the dimensionality reductions algorithm, and then that can be used for we can do some sort of analysis for prediction for the this heat wave analysis using the ML model. Then there is a wildfire and some sort of predictions where we can use some sort of climate variables that can feed into the ML model, and then we can look at the wildfires, which is basically directly monitoring from the remote sensing data set, and can be used to model that ML model, and then basically can be explain the historical pattern. Once it is developed, we can also use some sort of, let us say, pyro CB forecasting model that can be used to predict the wildfire in different parts of the world. Similarly, we have talked about floods in the previous slides also. When we are integrating the remote sensing NGIS and AI with together, we would be able to do some sort of more rapid generation of the flood maps, flood intensities, flood extent and flood depth also in different parts of the world like that. What is the challenges and limitations? When we are talking about AI or remote sensing, the data quality is the bigger issue, because whatever the data you are inputting in the model, it will provide the results like that. So, and access, it is also important, what is their availability. Model interpretability, suppose we are using some sort of black box model for deep learning model, it might be possible that they may not give you the correct interpretation with your input variable and the target variables like that. So, model interpretability can be also be improved when we are using some sort of advanced AI tools as well, or hybrid tool, or let us say those tools which has a interpretation terms also involved, or SHAP for example, a kind of computational demands. It basically, when we are dealing with the high resolution data set, high volume data set, we need to have some sort of more computational infrastructures. That is a one primary requirement when we are talking about remote sensing and AI integrations like that. And ethical and privacy concerns also. Sometimes we are doing some sort of surveys or in a populated areas, maybe there are some regions which can be not be openly for public, or let us say it has some sort of privacy concerns. So, using these maybe we can we can have a multiple these kind of the limitations that can be improved to do some sort of more better insight about AI integration with the remote sensing, and can give us more climate extremes informations like that. What is the future direction in innovation? Using these types of AI and remote sensing integrations, we can do some sort of edge computing, which means a technology for processing the data at source. We do not have to wait for very long period of time to get the corrected data set. We would be able to do that in a analysis from the source itself, and we will be able to get very real time alerts from the data set. When it has been corrected very fast, we would be able to get the data set, and that can be used for real time analysis, and that is helpful for real time alerts like that. Data fusion, that is another future direction where we can combine multiple sets of data sets, satellite, drone and ground data set for analysis, and that can be used to do some sort of explainable AI system that provides understandable insights about the processes as well. So far we are talking about some sort of black box model, but it also tell you about if you are giving some sort of input data set, how these input data sets are has a relationship with the target variable, or how they are behaving together, or what is the sensitivity like that. So that can be done using the explainable AI, and that is basically a future is where we can look at the hybrid or physics informed AI system for different purposes like that. So what is the key takeaways of this lecture is remote sensing in AI are powerful tools for climate extremes detection. When we are integrating these tools together, we would be able to systematically improve the spatial, temporal and analytical precision and predictions. What is the future research? It is basically addressed to the limitations and the ethical uses, plus data integration, plus the real time application of the remote sensing and AI approaches, so that we can have better more efficient early warning system, because we have more efficient data sources or more correct data sources at the real time, so that we would be able to tell more about the flood patterns or different types of climate extremes in a very short period of time like that. So this is all about for the today's lecture. In the next lecture, we will talk about the role of ecosystems in mitigating climate extremes. Thank you so much for your listening.